So thank you everyone for tuning in to yet another episode in which I talk about issues related to public transportation. Now, a couple months ago, I streamed about bus commuter rail interface, which is how buses connect with commuter trains in Vancouver. And this would also cover like the more commuter rail like rapid transit. So let's not talk about that. Let's talk about how buses mesh with local transit. So what I mean by, or not local transit, local rail. So what I mean by local rail, I mean something that is either the subway or light rail, or some kind of light rail if it's not like just an on-street tramway, which is in many ways an upgraded bus. Like a BRT on, like I want to say called BRT on rails, but BRT is in many ways a tramway on tires. And yes, I know that in Latin America sometimes they make it like it's a metro on tires. It is not a metro on tires. It is a tramway on tires. Metro on tires would be with full grade separation, which is not how either Bogota or Curitiba. No, that I'm saying like the but Curitiba. So neither Bogota nor Curitiba works that way. So so think about it as how buses connect with things that are either rapid transit or like on the spectrum of rapid transit, like Stadtbahn is rapid transit to me. American style light rail is like legally by definition there it's not rapid transit, because in American and Canadian parlance when you say rapid transit you mean full grade separation, but conceptually when you think of it like the hierarchy of transit, light rail needs to be thought of as like kind of like the subway. In fact, thinking about it right now, in North America, which cities have both light rail and fully grade separated rapid transit system? So Toronto has streetcars, but I think they're even mixed traffic, let alone being on street. Eglinton actually might be is I think it's under construction as a Stadtbahn. Boston, Philly, and San Francisco all have Stadtbahns. But like light rail that's more like the more modern kind, which is kind of weird because Eglinton is being built as we speak, but I think it's about to open. It is, and normally I would not fidget about Toronto, but actually Toronto is really important for this. Line 5 Eglinton, it's still under construction. Okay, it's not already open. It is planned opening this. The first phase is scheduled to open this year. Great. Okay. So as I said, about to open. So Eglinton is LA. Yeah, you're right. And yeah, Jersey City. You're right, because Jersey City has Pass, and then it has the Hudson Bergen light rail on top of that. You're right. Yep. Good point, Brock. No, Boston, as I said, is a Stadtbahn, which is like a subway with light rail branches. Is the right way to think about it. So anyway, I'm going to talk about how buses fit into the hierarchy with this, and normally I don't talk about Toronto that much, but it's actually really important to talk about Toronto, because I think of maybe Toronto, Chicago, LA, I guess also Vancouver as like the main North American bus grid cities. So how rapid transit fits into the bus grid is actually really important. For the other main North American example, there is Boston, because Boston, famously, this is how the street network looks. Well, right now it's on my computer looking blurry, but you know what I mean. If you know anything about Boston, yeah, so there's a grid here. It is like maybe a few square kilometers of grid. I'm pretty sure all of this is reclaimed. There are two parallel streets here. That's a grid, right? Oh, they have a little bit of a grid in Back Bay because it's Phil. But yeah, fundamentally, yeah, this is the Boston street network. Yeah, not a grid. So now the Boston Street Network is of course the more common one in Europe, uh, and so that is also an example. They're also going to give us a set of examples of bus rail interface. Now New York is a gridded city. However, New York, unlike Chicago, does not have a grid. Um, Now, the Manhattan grid, I think, is much more famous than the Chicago grid, but also the Manhattan grid is just Manhattan, and Brooklyn has not just its own grid, but several of them. You can even see a little bit of that as we go through and the thing starts loading very slowly. Um, they're making announcements for eventual launch. I'm sorry. Um, yeah. And so yeah, a bunch of different grids. So this is not Boston. This is not like London or anything like that. But it's still not a single grid, and that's going to matter. Now, uh, so again, we're going to discuss two kinds of cities, and Toronto is actually a really good example. Probably the largest transit city among the ones that I mentioned before for grids, because Vancouver is small, Chicago is American, and Los Angeles is American and also Sunbelt. Or rather, Los Angeles, so, side note, when the term the Sunbelt was coined, it was the 1960s. I believe the term, I don't know if the term was invented by Kevin Phillips in the emerging Republican majority. It was certainly popularized then, and at the time, LA was considered to be the epitome of the Sunbelt. California was the epitome of the Sunbelt. Fast growth, like literally sunny, and conservative values in the 60s. Especially, I don't think in LA proper it was as much as in Orange County. Like Orange County, California was a very important source, was a very important place for the emergence of the new right. And like a specific kind of new right that blended very conservative middle class urban, or rather suburban values, with a lot of Cold War hawkishness. Southern California's economy was very militaristically oriented, with World War II and then the Cold War, and then there was actual like a local recession there when the Cold War ended because of the peace dividend. So the sun. So historically, when people said Sunbelt, they absolutely meant Southern California. Probably much more than they meant Texas. And today, people mean mostly Texas, Arizona, maybe Georgia, which is kind of weird to call Sunbelt because yeah, it's warm, but I mean rainy as all hell. The alt-right, I've never watched Arrested Development. I think I watched clips of Arrested Development on YouTube that total maybe 2 minutes, and the answer is, so I don't know. I don't think the alt-right is Orange County. The alt-right is very different. The alt-right is much more Rust Belt oriented. And I don't think it's Orange County expats. Yes, the people who moved from California to Arizona and Nevada and Texas tilt right, but they're not the core of the alt-right. The core of the alt-right is people in deindustrializing or like fully deindustrialized parts of the first world, and not just the United States. Like here, for example, the core of AfD is Saxony and Thuringia, the kind of equivalent of Orange County in terms of like conservative, like hard right values would be Bavaria, especially the parts of Bavaria that are not the city of Munich, but absolutely are the suburbs of Munich. Oh, Stephen Miller. I mean, first of all, I would not call Stephen Miller an intellectual. But second, okay, the person who coined the term alternative right, where was he? Because I don't remember if he was California. Because this was specifically someone who might have even been Jewish, who coined the term right after Obama won the election as kind of like a shock against. Okay. Okay, note by the way that all of these things are not especially Orange County. Are you gonna actually tell me history influences? Paul Gottfried, yeah. Pennsylvania. Sorry. On Songjiang trams, no, I don't know about the trams in Songjiang. All I know about Songjiang is that it was historically the county town until it was eclipsed by Shanghai. And at this point, I think it's in the same municipality, so it's technically a neighborhood of Shanghai. I told you everything I know about Songjiang right now. So Steve Bannon specifically was trying to make it in Hollywood. But anyway, so before we get too distracted, or sorry, after we get too distracted, so public transit works hierarchically. This is core to how public transportation works, where the hierarchy has several levels. How many levels depends on size of country, size of city, where you live within the region. So first of all, there's Intercity. It's the highest level in the hierarchy, and when you do mainline rail planning, you plan around the highest level first. So for example, if you do the Swiss Takt, so the way that the Takt is planned in Switzerland is they plan it around the intercity connections first. Now, it's not going to show up very well on Google because this is on Google Earth, because it's going to take forever for the train overlay to load, and it's also going to be geographic, and you basically cannot study the Takt except through schematics. So let's see if we're getting something. No, I don't want you to translate this. Okay, so this is the original system. There are okay, so this is the system as it is planned to be. So this is the core intercity system with cities like Zürich. The core is Zürich, Basel, and Bern. Note that, I don't know if you see that far. Wait, what? What the hell is wrong with that? Okay. So, you start by planning this bit, and noted by the way that Genève is not part of the system, it's too far out. It could be, but it's not really a place where you're going to have timed connections, because it would be just two local trains, or maybe to some French regional trains, but that would require relying on French punctuality, which is even worse than German punctuality when they're not on LGVs. So you plan this is the highest level, and then you plan the lower levels, like the regional trains around this. Now, often regional trains can be permitted to intercity, like St. Gallen is not a large city. Schaffhausen is not a large city. So you plan so there's a hierarchy, and you plan from the top to the bottom, and in Switzerland it's very integrated, so you start by planning intercity, then around that you plan regional, then you plan commuter. Now, if there need to be timed connections farther, not farther as in going farther out, as in farther down the hierarchy, farther, not sure. Then you plan around them, because you need to know how it fits into the system, into the broad system, to know, for example, where you can actually set up these knots. So these are called knots, Knoten. Where, in the same way that Zürich is a knot for the entire intercity network, or Olten or Bern, you could, like, some regional stations that are not depicted could be knots for a local system where a bunch of buses or trams connect with commuter trains. Now, that is the topic of the commuter rail video, so I'm not going to elaborate further on this, but I'm just going to just highlight how the hierarchy is planned from the top to the bottom. And again, there has to be some kind of hierarchy. Now, within a city, again, we're going to try to ignore commuter rail. So within the city, I'm going to move my head so you can actually see it. So that local trains should have priority over trains running express. How does it interact with that? Good question. The answer is that it depends on where we're talking. So when you run a metro system, it's generally more important to have local than express trains. Um, when you run, and this includes a metro-like commuter rail network. Now, what counts as local depends on, usually the standards are like for wider stop spacing on both local and express trains and commuter trains. But the but again, it really depends on where you're going. For like stop spacing in general is something that depends on the relative and not absolute density. The issue is that if you, and this is also going to matter for buses and trams, is that if you double the density of like let's say your bus zone, like you're on a bus, and if you double the density throughout, then there's going to be double as many passengers you're skipping at every stop that you wish to skip. But also, there's going to be double as many passengers going through who would be slowed down if you made that stop. So it's a wash. However, relative density matters. So if you have uniform density, if you have isotropic density, that is the situation in which the bus stop spacing should be the shortest. If you instead have a very prominent node, then you want to have wider stop spacing because maybe all passengers are going through that node. Let's say and we're going to start talking about how bus and rail interact right now. So I'm actually going to not bring a European example because in inner Berlin and in Paris, yeah, there are buses, you don't need them. So I'm going to give a New York example, which is that at the end of the subway system in Queens, there are two such ends for the most part. Jamaica, which is the double end of Jamaica Station, which is where you connect with the LRR and JFK, and Jamaica Center, this one, where the buses connect. So this is kind of a double terminal. It's a good design because you don't want all the bus passengers to swarm one station. It would overload the entrances. At Flushing, there's only one terminal, and buses, that's the other one, the buses are converging at it, and this is maybe not anymore, but for many years this was the busiest subway station in New York City outside of Manhattan. It's only served by one line. I think that maybe this station, like the intersection between the 7 and the Queens Boulevard line, serving the EFMR and 7, 74th Street, Jackson Heights, might be busier. Either way, the difference between this is small. But this is a transfer station and this is not. And so the situation with the bus rail interface here is basically everyone from Eastern Queens who gets on a bus going east-west is going to either Flushing or Jamaica Center for the connections to the subway. This, in turn, means that these buses should have wider stop spacing. Why? Because the number of people who are being skipped is the same as an origin, because the population density is fairly uniform. Like there are denser and less dense areas, but it's not like there's like a bunch of towers around each bus stop or anything like that. But you're not skipping any destinations because all the destinations are always Flushing or Jamaica. So the buses are actually taking people where they want to go, and this allows you to have slightly wider stop spacing. So this is an example of bus rail interface at the edge of a subway system. This is really important. If you're uncertain about the bus stop spacing, these routes should have wider stop spacing relative to your state network, which, as you can tell, is not a grid. There are some local grids, but it is not by itself a grid where you can just say there's a stop every 400 meters or every 500 meters. 400 and 500 meters are usually average stop spacing that you should be shooting for, with like moderate levels of centralization, but like not exactly ISO, nothing that's exactly isotropic, but also something that's not especially spiky. Something else that's spiky and is technically at the end of a subway system, but that's not why it's spiky, is east-west buses within Vancouver. Vancouver proper. Now, Vancouver is a grid, and bus terminals. You're asking about bus terminals. Okay. So, okay, I'm gonna take these questions and talk about Vancouver. Actually, I'm gonna talk about Vancouver first. In Vancouver, if you're on an east-west bus, there's a very good chance you're going to UBC. And this means that even though the population density in this area is fairly high, Fairview is rather dense. Kitts, it depends on which parts of Kitts, but Kitts is a pretty dense neighborhood. Like, it doesn't look incredibly dense, but like when you have these missing middle and some mid-rises, it like all over, and it's a residential area, you're actually getting like decent density out of this. However, so here they have local and express buses. The express buses stop every kilometer, the locals every 200 meters. And they're both very, very well patronized. This is the issue is that, and again, it's partly the end of the subway because the SkyTrain only goes as far as VCC Clark, or Commercial Broadway. So so for students bound for UBC, there are many. This is a very large university in the typical Canadian style. So there's a wave of students going from here to here. Now, there are no non-stop buses. I believe the plans when the subway opens to Arbutus later this decade, I think in 2 years maybe, they're going to run a non-stop bus because it's going to, so like at this point already there are two buses that go, that are dedicated to doing SkyTrain to UBC, the 99B line, which is the busiest in North America, which goes from Commercial Broadway, which is where the Expo line stops, on Broadway and then on 10th to UBC. The other one, the Expo line only stops at Broadway. The Millennium line stops at Commercial Broadway, but also has a stop at VCC Clark. This is not an Expo line stop. So, as a relief, there's the 84 bus. That's the one I rode because I lived north of 4th. So it undulates a little bit in this rare violation of the grid, but then runs on 4th. And will get you to UBC faster if you're on the Millennium line. Not because you have one more stop on the subway on the train as opposed to on the bus. That's not that important, but rather because there's less traffic. I lived right next to an express stop on the 84 as opposed to a local on the slower buses, Vine Street, and I kept timing it and it was very fast. I think the average speed on this section I rode to Vine Street to UBC was like approaching 30 kilometers an hour. This is a bus that did not have dedicated lanes. It had signal priority, but only the same signal priority as all other through traffic on 4th Ave. On the cross streets, the light only turns green if you hit the back button. Again, this is like end of subway to an important destination. Now, in this case, this is not something that should be planned in the long term because what they should be doing is just sending the subway there. UBC is a huge destination. In general, like if you have this giant destination to the point you need to run buses dedicated to it, build a fucking subway. In this case. So this is an important thing about this interface is that in the most extreme cases, this shouldn't happen. To give Vancouver credit where due, they're building it. They're building to Arbutus and they're planning to build all the way to UBC. They just have construction cost problems. Now I'm going to take the questions. So Blue Power Van, welcome. In Queens, the area closest to Flushing, but not the Waterford, what's the relative importance? Good question. So, probably the most important thing, especially when it's not close to Flushing, like if we're not talking about here, but Bay Terrace, the most important thing is to improve frequency on the LARR and integrate the fares so that instead of having to go on a bus that goes especially from here, the street network is not great for going to Flushing. Usually when you have a hierarchy of streets, the streets do lead you to major destinations, but somehow northeast of Flushing it doesn't quite work that way. So you need to do something like this. So anyway, instead of meandering through these streets to go to Flushing, you would just go whip on much less jammed north-south street. You're avoiding Flushing. So yeah, part of the thing. So one of the rules about this kind of interface is you should actually upgrade your commuter lines if available, and they are here and they are here. In other cases, they're not. Always. So in New York and Boston, often it's like upgrade the commuter rail so that it can act like urban rail within the city. This is probably the most important thing. I don't think you would even need bus lanes if you're just going on like Bell. Like I don't see Bell, for example, or Utopia or things like that needing dedicated bus lanes. So that's kind of a freebie. I want to say stop consolidation is important because, again, these are buses that are very much not isospectral, isotropic. Isospectral means something in math. But that's, I think, being done as part of the bus redesign. They're actually, I think they're calling these rush routes or something. These routes specifically, I think, are getting fewer stops. And about running more buses, that's also important, and unfortunately that's not being done. So among the three things you mentioned, timetables, I mean, it's not really a matter of timetable. Like, it's not like the timetables could be written more cleverly. The important thing about this bit in the hierarchy is we're talking about urban rail and not commuter rail. Now, the LARR is commuter rail, and I'm mentioning it, but the LARR is here relevant in that it could be like an urban train running every 10 minutes. And when you're running every 10 minutes, you don't really time the transfers. You could, but it's very unreliable. I would not do that. Certainly would not time transfers to the 7, which runs every 4 minutes off peak, 5 minutes off peak. So when you have very high frequency, you rely on untimed transfers. Now this is also something that means that the bus regime for a small city is not a subset of the bus regime for a large city. So what do I mean by subset? If you take a large city like New York, like Berlin is much smaller, but it was one of the largest cities in the world in the first half of the 20th century until a certain unfortunate mishap involving really ugly facial hair on some Austrian dude. Until then, it was one of the largest cities in the world, so the U-Bahn is a rather large network. If you look at how a smaller city's subway network looks, often it's like it would be similar to the first 3 lines of the larger city, and this is much clearer if you see it in, let's say, the Soviet bloc, just because they had much more systematic. Still have much more systematic planning around these radial systems, where if you look at how the metro system in, I shouldn't call them a small city, but like it's a relatively small network in Praga, Warsaw, Kyiv, honestly, it does look exactly like or almost exactly like the first 2 or first 3 lines that were built in Moskva. In contrast, buses don't have that. Like the bus network in a small city will not look like a thinner version of that of a larger city or a less frequent version of that of a larger city. Now, you could do that, but that would not be optimized. In a small city, what you want to optimize for is timed transfers between the buses, which you can't do at very high frequency because they will just not be on time ever. In the United States, the practice is to do it hourly. They could do it half hourly if they wanted. I think some places are doing that half hourly, just very rare. I think Jarrett Walker was recommending that for Richmond, Virginia, in the evening, whereas in the daytime it would be 15 minutes without time transfers, because you can time transfers if you run every 15 minutes, but it does require some bus priority to avoid traffic. In Vancouver, they can time the buses. They don't time the transfers, but they can run the buses on a schedule every 12 minutes. But I showed you the thing with fourth hour. I mentioned that there's very high levels of not bus priority, but general traffic priority on the street versus on other streets. And the grid works very well with that because it distributes traffic. And so you want to do time things every half hour, maybe every 20 minutes, kind of, if you're kind of borderline. But beyond that, you want to switch to untimed transfers, and then the network will look different. And again, in New York, the median, I shouldn't say New York because I haven't checked it everywhere. In Brooklyn, on pre-corona numbers, because I did this in 2018, in Brooklyn, the median bus, this is all weighted by route kilometers, runs midday off-peak every, I think, 13 minutes. Basically half run 12 minutes or better, half run 15 minutes or worse. There's like maybe a tiny proportion that run somehow every 13 or 14 minutes and somehow they're the median. But like it's usually not, like usually the ones that are 12 minutes or more, or 10 minutes or more are like a divisor of 60. It's just, again, almost perfectly 50-50 between 12 or better and 15 or worse. A lot of these, of the 15 or worse, are like lines which shouldn't really exist. So like the buses that are relevant are probably on average about, median about 10. So yeah, you're not doing, yeah. Berlin does time transfers on a 10-minute takt. On the U-Bahn. And sometimes even on a 5-minute takt. But usually 10. Sure, no problem. Funny mustache. I don't think it was funny, just facial hair was butt ugly. Is having too many stops a legacy of pre-mass car ownership? No. The United States never did stop consolidation, Europe did. Because in Europe it was just more systematic post-war planning. I believe it's a post-war thing, that there are clear bus stops as opposed to you stop wherever you want on the route. It's not like a pre-car ownership, like it's not a legacy of pre-car ownership, it's just, at least in the literature that I've read about North American versus European/Australian bus stop spacing, it's systematic planning. Okay, Hikoki, you're asking me about bus terminals versus on-street stops. Now, I love bus terminals, but that is for one reason and one reason only. The reason is that in Tel Aviv, I don't know if it still exists, but certainly there was when I was growing up, a central bus station used for intercity buses because the trains were only starting to stop sucking at the time. And also if you were going to Jerusalem, you may be able to tell if we see the rail overlay. Yeah, this is the historic railway from Tel Aviv to Jerusalem. Yeah, no, the buses were the buses did the same trip in half of the time. Tel Aviv to Jerusalem. Tel Aviv to Haifa was a good train, but I mean Tel Aviv to Jerusalem only became a good train a couple years ago when they opened this. Casually through a little corner of the West Bank, because why wouldn't they? So in Tel Aviv they had central bus station. I don't know if it still exists, but in Hebrew it's called Tachana Merkazit, like central station, but everyone would call it Tzachana Merkazit, so tz instead of t at the beginning, which changes central station to central stench. It was just really seedy in there. to the point that one popular teen comic portrayed it as a literal gateway to hell. The main character is lost in its labyrinthine passages and ends up in literal hell and is only rescued when people are trying to do when some I don't know, emo, like, I know where they're going through the term, like, we're in some, let's call it weird kids, and I don't remember the social groups of Gen X high schoolers, did a summoning of a creature from hell, and of course he was in hell at the time, so they summoned him. That's bus stations. Do not do bus stations. It is not good to do bus stations. I can see it for intercity purposes, but even then, there's a reason street, like curbside buses are like gaining at the expense of bus stations. Like, bus stations are good if you're trying to centralize things, which is again for intercity purposes. So you pick a location, and so you want to pick a location that's accessible by highway because the buses go on the highway, but is reasonably central. Now in Boston, it's south. They do South Station with highway penetration, but for example in Berlin, it's at the right. It's, I think, here. And in Munich, in München, it's actually pretty close, and it's Hauptbahnhof. It's near Hauptbahnhof. I think either one or two stops on the S-Bahn. In Paris, it is Gallieni, so on the Periph. In New York, they actually built Port Authority for that, but Port Authority, besides being kind of terrible to the point they're spending, they just announced a $10 billion replacement project, which is worth not quite zero, but also not much more than zero. So what they're doing with that is that there's an express bus lane in one direction, like only inbound and only during the morning rush hour in the Lincoln Tunnel. So that's for suburban buses that feed the bus station, and there's just not enough space for the massive rush hour buses on the street because it's all centralized because the buses go through one highway, and that's not how buses work usually. The whole point of buses is that they use the fact that there are many, many streets. And when you don't have many streets, for example, you don't have enough water crossings over the very wide East River and the very wide Hudson River, then you have a problem, which is why this should be done by rail. This actually affects the issue of night buses in New York, because in New York, you can't meaningfully run night buses because there aren't enough road crossings between Manhattan and either Brooklyn or Queens. In most cities, they can run night buses. Again, in the same way that a small city's bus network is not a subset of a larger city's bus network, a night bus network is not a subset of the daytime. In Vancouver, for example, they have a grid. The buses run every 5 to 8 minutes. It's untimed. But at night, they switch to half-hourly timed connections in downtown Vancouver. And again, New York can't do that because how the hell are they going to get from Brooklyn to Manhattan? There are 3 bridges and 1 tunnel, and there's way more subway crossings than that. Same thing with Queens. Click here to reload player. Okay. Yeah, so what else? Oh, Japan's not done buses. Yeah, but Japan, I thought Japanese buses just suck. I thought the issue was, is my internet not working? My internet is not working. I don't know if people are saying this. Obviously it's being recorded. So yeah, I thought the UK had longer bus Okay, we're back. Okay. So, Borners, are you saying this? So in Japan, I thought the buses just suck. And usually the main way you get on the train is by bike or walking. But that's something specific to the fact that, remember, there's a hierarchy. However, if there is such great coverage by subway lines, which can happen in a very large city, you can just walk to the train. In New York, yeah, you can take. We were talking before about buses into Flushing in Jamaica, but most subway riders are not coming from east of Flushing or Jamaica. They walk. Yeah, no, the bus. Yeah, exactly. The Port Authority bus terminal is bad. Tel Aviv Central Bus Station, as far as I remember, is worse, but I have not been there in over 20 years. So, we will see. I mean, but yeah, no. Bus terminals are just sad. If you're doing urban buses, you should not use them because the whole point of buses is that they have much better coverage. Like, just compare the extent of like a bus network with that of a metro network. Even, let's see if I can get a. Thank you, Flix. No, shut the hell up with your SEO. And Omeo. Okay. Verifying you are human. The dehumanization of the Jews is reaching nightmare proportions. I'm sorry. Verify you are human. Verification successful. Great. Okay, I don't want their trip planner. I want the map. View line map. Okay. So this is schematic. My opinions about schematics are well known, I think. But yeah, so tons and tons of lines, and this is in a city with a very, very large metro network. There are still more bus lines. Because any street can be a bus street. Now, you wouldn't want to do that in every street. You don't want to spread yourself too thin. If you don't have a grid, then the side streets are not really good through routes. If you have a grid, then every side street can be a through route. It's just that not all of them should be. Now, Manhattan maybe is busy enough, and with the one-way pairs, every avenue in Manhattan should have a bus. But for example, in the parts of Brooklyn that have the same kind of street avenue system, not every avenue gets a bus, and that's fine. Even avenues that do go through. Now, there's somewhat of a hierarchy here in that not all the avenues quite go through. Let's say, you see how a bunch of these are backed, these are streets, not avenues. Some of these streets back up against the future IBX, the Bay Ridge branch. But even among the ones, like, I don't think that this was included in our bus redesign, like this street. And the avenues ones go like this. Not every one of them gets a bus. Every one of them could, or almost every one of them could get a bus, but it's just not efficient. You do want to consolidate in order to maintain frequency. And so that's the issue of route spacing, which is important and also incredibly difficult. It's two-dimensional optimization. Now, thankfully, anywhere where you actually need to do it, you have a subway or some kind of subway-like light rail system. So you want to use the streets that hit the subway, of course. That's pretty standard. And again, you want to spread the buses. Like, you do want some consolidation for frequency, but I can't give you an exact rule of thumb for beyond what frequency you want to start splitting. The thing Eric and I drew for Brooklyn 5.5 to 6 years ago was 6 minute service. So with going nuts on bus lanes and on stop consolidation and some route pruning, we could actually get in Brooklyn to 6 minutes. In Queens, I tried and it's not viable unless you add a lot of frequency or unless you allow buses to connect with the LAR instead of the subway, which requires improving LAR service. And in so 6 minutes, 8 minutes is probably good. Probably at 10 you might want to start thinking about fewer routes depending on the route spacing. Certainly by 12, 15. But but if you're single digits, you probably would want more routes to spread out the buses to avoid having too much traffic, to avoid having too much bus bunching. Buses, once the frequency goes to like well below 10 minutes, like talking 7.5, 6, 5 minutes, they start bunching, and essentially the buses can't meaningfully run more than every 3 minutes unless you have basically BRT levels of route priority. And usually if you're running that many buses, build a fucking subway. It's the case on Utica and Nostrand in New York. So that's how they fit on a subway system that has a bunch of routes. Like you want to make sure to connect. Now, I promised before that I was going to talk about bus grids that are not New York, because New York is not a grid, it's several. And I was going to talk about Toronto, Vancouver, Chicago, LA. I talked about Vancouver a little bit, but in Vancouver it's in the context of the importance of UBC. So let's go in Toronto a little bit, because there is the issue of grids and something that Jarrett Walker calls the grid accelerator. So Jarrett does not plan top down in the hierarchy, but bottom up. So Jarrett, what do I mean? It's something that Jarrett plans bottom up. Jarrett just thinks about buses, and will not make recommendations like, here you build a train. That's not what he does. So, from his perspective, it starts with the grid, and Toronto's grid is not perfect, whereas, for example, Manhattan is a very relentless grid. But the important thing about Toronto is that even though we are seeing some side streets not go all the way through, the main streets are at pretty even spacing, and they all go through. And they form a grid. I mean, okay, this one doesn't, but they all go through almost the entire way, most go through all the way, and they again form a grid. So the buses are kind of forced to be on specific grid routes. The buses in most cases predated the subway. I think at the time the bus grid was formed, and when the TTC was formed in the 60s, at the time, the extent of the built-up area was only about the extent of the city of Toronto today, which at the time was like, I think, a county, of which not everyone lived in the city of Toronto. Later they consolidated Toronto with the county, which is generally considered among the snobbish urbanists of Toronto to lead to negative results, because that meant that the working class outer neighborhoods started having opinions, and those opinions were not in favor of like Jim Jacobs style slow transit, leading to the debacle of Rob Ford. So the buses, again, it's two-dimensional, but you don't need to do that much route optimization, because if you have this kind of street network, you don't need to think too much where the buses go. They go whoop, whoop, or no, that's not the bus. This is the bus. This is the train. They go whoop and they go whoop. At the time they started this in the 60s, wages were much lower. Car ownership was not universal. Their buses ran almost to the edge of the built-up area at very high frequency. Again, frequency was cheaper than it is today. And the system in this case is that the subway can be thought of as a grid accelerator. What does this mean, grid accelerator? It means instead of thinking about, let's say you take a bus, and I don't remember these street names, so I think this is York, but I'm not sure. So instead of taking something to Yonge and then taking a bus to Yonge, the subway lets you take a subway to Yonge and then take a train from Yonge, or from the Spadina Expressway. And so the subway in that case works with the grid. It doesn't cut the grid. And yeah, the Toronto subway is currently in grid routes. It's Yonge, Spadina, Blue Danforth. They're building Eglinton as a weird Stadtbahn, which is just a compromise of doing the worst of both worlds between what David Miller wanted and what Rob Ford wanted. In Vancouver, I'm just gonna switch to Vancouver, even though like it's not as pretty, the grid there, but I know it better. So in Vancouver, the city and parts of Burnaby are gridded. The grid breaks down the farther east you go, or across the inlet, or downtown. But downtown's there are buses that go downtown from not downtown, but mostly they just go through here, and then there just are grid routes in like north-south grid routes in East Van, or east-west grid routes. So the way that it works is there's this grid. These streets are numbered. So 4th is number 4, 84 is an express. So 4 goes like this to downtown Vancouver. 44 is an express version, and then 84 is the express version that goes to VCC Clark instead. 9 or 99 express. King Edward is 25th. 41st, all of these go to UBC, and then 49th, I think it's this one. That also goes to UBC, I believe, but it doesn't go right. So the issue is that, remember now, 41st is within the city. 49th, I think, maybe 49th doesn't go to UBC. I don't remember. 49th is the one that ends at Metrotown. These are the main ones. There's like 33, but it's not as busy a route. Because 33rd doesn't go all the way through. Then the north-south, you just need to memorize the numbers. So 2/22/32, also 7, which is another overload before does this. 7 is Alma, right? So McDonald is 2, 22, and 32. Arbutus is 16. It goes to downtown Vancouver and then re-emerges as a north-south and east Van. I'm forgetting where, I think on Night? Yeah, I think on Night. Then, and I don't have Q cards in front of me. This is like how I remember a city that I haven't lived in almost 10 years. Because the grid is that simple. Granville, I want to say is 15. And it's kind of like the last one that's semi-useful. I think 17 is Oak, but it's barely used. 10 is Cambie, barely used, and the reason these are barely used is that the Canada line goes north-south in Cambie, so why the fuck would you ever ride a bus? That's actually really important. When you build these grid accelerator routes, and Cambie was a grid accelerator route, then you're killing the bus that's parallel for all intents and purposes, and also, or not parallel on top of it, to a large extent also the nearby one, so this is also killed. Main is 3, and it's actually a very busy route. Fraser is 8 and very busy. Again, Night is I think 16. Commercial is 20. That's as far as I remember. And commercial is, at least that was the second busiest in the city after Broadway. Now, bear in mind, the extra line is on a grid accelerator. It's slant. It's diagonal. And Kingsway is 19. It's kind of parallel to the extra line, but not quite. It serves different parts, and it's also very busy. So now the Millennium Line is kind of a grid accelerator. The 99B line, the Vancouver Express, the Broadway Express, used to run much farther east. At lower frequency though. And then the Millennium Line just killed that. I mean, who needs the express bus when you have Skylink? The 9 bus route still exists. It runs all the way, I think, to Boundary, to city limits. But I think actually quite a lot of buses turn at commercial. Anyway, and again, the 99 turns at commercial. Because the whole point is that the grid accelerator kind of kills the need for the bus, to even exist. And I suspect it's going to happen. Like, certainly they're planning to kill the 1990 when they finish even to Arbutus, because the express lines are going to, as I said, go Arbutus to UBC. And then, yeah, you can have the local bus, which is not going to be nearly as strong. Now, today, it's, yeah, and so, I'm not sure about today, but 10 years ago, 990 was by far the busiest bus route, and then the 20 on commercial, and then number 3 was the 9. So the Vancouver was so strong it had both the first and the third strongest bus route. It's never going to get it's never going to be this once this opens, except specifically because of the partial opening Arbutus to UBC is going to be very strong. So this is what happens with the grid accelerator route. It actually reshapes the bus network, because it means that you're going to have much faster travel along the line than orthogonally to the line. And this means the buses that are parallel to the line are going to basically die. Like, if, probably when they open SkyTrain all the way to UBC, yeah, Broadway's still gonna have buses. Forth is still gonna have buses. They're just not going to be very busy. There's a reason they're projecting 300,000 weekday riders from the full opening of both phases of Broadway, the one that's under construction and the one that's in design. I mean, yeah, some of it is induced, but some of it is people who are currently riding kind of slow buses are gonna switch to much faster SkyTrain. Even the fast buses, they mentioned before, they used to ride. I lived optimally relative to the bus, because I lived, again, on Vine and First. The bus on 4th Ave stops at Vine. The plan for SkyTrain is not to stop at Vine, because it's going to make Arbutus stop. It's going to make an Arbutus stop based on Broadway, not 4th Ave. So even though I lived optimally based on the bus and pessimally based on the train, it would be a wash for me on trip time, including walk time, to be able to rely on the bus versus if the train existed, and the train is more comfortable. So yeah, the buses would keep existing, but at much lower intensity. And in contrast, what's going to happen, I expect that buses that connect to SkyTrain these buses are going to become stronger. So again, things like the 16, the 22232, maybe the 7, just because of Alma. And so that's an important thing to keep in mind when you're doing this kind of grid extension. This is how you're going to have buses and these kind of local urban rail interact. It's going to require you to shift bus service to feed the trains better, and this is even if the buses are still formally a grid, in the sense that in the same way that there's still a bus in Canby, there's still a bus in Oak. The buses on Canby and Oak have low ridership at this point, but this is still a grid, and if they decide to consolidate away the, let's say, Oak bus or something, that's still going to be a grid. A grid that misses one route that's been replaced by a subway is still a bus grid. So even if the topology of the network looks very similar, the relative intensities of different bus nodes need to change, and this is really important. Oh yeah, the predecessor did go to, okay, yeah. The Broadway wire, yeah, I mean, the fact that the wire in Vancouver is not being extended properly is annoying. Like, in Vancouver, and I'm just gonna free associate and dump on Vancouver, because why not? So Vancouver has an extensive network of trolley buses. I don't know if it's the busiest in North America or the second busiest after San Francisco. I expect that in terms of ridership it might have overtaken San Francisco, because San Francisco was hammered during Corona. But anyway, lots and lots of trolley buses, but first of all, these are not any of the historically crosstown routes, so there's no trolley wire on 25th or 49th. Maybe on 41st there is, actually, I don't remember. On Broadway there is, and on the north-south there is, and on Hastings there is. But on the routes that have local and express service, only the local buses are trolleys, and the express buses are diesel, so they can overtake them. Now the thing is, with modern tech, with modern trolleybus tech, the trolley buses always have batteries to extend the range a little bit, minimum a kilometer, usually several kilometers of off-wire capability. I think the current state of in-motion charging tech, 50% of the route needs to be wired, and the maximum off-wire range is either 7 or 10 kilometers. Now it depends on things like the weather. The places where I've seen this quoted are in Central Europe. I think maybe some Swiss or Austrian cities, or maybe Solingen. So Solingen is much. It's kind of weird. Solingen is much farther north, but it's also downriver because Solingen is in the Rhine-Ruhr, so it's might actually possibly warmer in winter. But Vancouver winters are warmer than German winters. So yeah, the battery on a battery bus degrades in winter. Essentially, the issue with that is that I think part of it is the battery just physically degrades in winter, but also there are heating needs. The thing is, the internal combustion engine is not perfectly efficient. There's actually fairly low efficiency in converting the chemical energy of the fuel to mechanical work. Now, energy, by like normal classical physics, is conserved, so the waste energy goes somewhere, and that's heat. So the waste energy heats up the bus, and that means that you essentially get free heating. Now, on a battery bus, batteries have much lower energy density than fuel. They partly make up for it by having by being better at converting this chemical energy to kinetic energy. But this means that there's less waste heat. So when you need to heat the bus, the heat needs to come from somewhere, and none of the options is good. I think in Duluth, Minnesota, they ended up getting I'm forgetting what kind of fuel the heater runs on, but the heater is separate from the battery electric bus. That said, again, we're not talking about full battery electrics. That's stupid. I'm talking about in-motion charging. I'm talking about having the bus run predominantly trolley, but extend off-wire a little bit. So this means the express buses should be using the off-wire capability to overtake locals on 4th and on Broadway and on Hastings. And also to extend off-wire a little bit. There's kind of a weird thing where there are two bus loops at UBC, a diesel bus loop and an electric bus loop. And if you're indifferent as to whether you're getting a local or an express bus, well, you need to decide. These are rather different places on campus. I have had that problem. I've needed to pick which bus loop to use. So you can go off wire and serve the diesel bus loop on an electric. The diesel bus loop is better. Like the electric bus loop is like one loop. It doesn't have enough firm. Let me see if we can find it. I think maybe this is the electric loop, like this, and then the diesel has much more space. It's here. So they're not widely separated, but not the same place. And yeah, so that's what you do with the bus grid at any rate, and how it interacts with trains. You should be building trains. Like if your city is big enough that you have a strong bus grid, the city is big enough to justify trains like Vancouver, or like the other American city. Okay, Vancouver's not America. Like the main American cities that have large-scale grids, which are Chicago and LA. In Chicago, there's the grid. The buses run on the grid. Now the L is not as grid accelerator-y as in Toronto. First of all, the L is much older. The L had a bunch of lines in the 1890s already. And then electrified, I think, 1897, 1898. That's when the modern EMU was invented. Oh, yeah. Soviet, oh god, yeah. Yeah, same. This is why, so this is why I believe every present-day trolley bus, including ones that are made for the American market, for like the handful of cities that have legacy networks, like Dayton, I think they can go a kilometer off wire. And then more advanced in motion charging lets you go 7 to 10 off wire, and I believe half the route needs to be wired. That's the state of the technology as of a couple years ago. It's probably improving, but it's not improving incredibly quickly. So anyway, Chicago, I would not quite call the L grid accelerators. They don't run relentlessly on grids or anything, because the whole point of the L is that the routes have to be able to terminate and loop back. Toronto also has that problem, which is how the Young University Spadina line. I guess just called the Toronto subway because they killed the line that they insisted was rapid transit on subway. You can already kind of see here how the network looks like. This is a very narrow U. Like you would never run through. Like this is always something you would do by bus. Just essentially two north-south lines that have been joined. And again, and Chicago has a kind of problem with routes that run one way to the loop and then loop and go back. Or the blue line, which runs like this. Now bear in mind, Chicago has a bunch of routes that run in freeway medians, like both branches of the blue line eventually, and the south, and not the south side main line. The south side main line is the old ones, the green line ones. The Dan Ryan branch, that's where the red line has been moved to. It's the free midway. It's midway. It's in the median of the freeway. And again, the buses mostly just connect right away as a grid, to the point that because the red line doesn't go all the way south to city limits, the buses do not act as a grid south of the end of the red line. They actually detour. And that has been a problem for bus planning in Chicago, because it means that you can't really go across town with that. Whereas the nice thing about these bus-rail interfaces is that when you have a healthy bus grid that works with the subway, you have buses that, get most of their traffic by people connecting to the subway, but as soon as that happens, you can automatically use the bus to also go to other bus stops on the same line, on the same street. And that doesn't really work if the bus has to detour to the point that you can't really use that. And so in the case of New York, I was bringing up the LIR, in Chicago there's also a bunch of commuter lines that should be used that way. But separately they're planning to extend the red line farther south. I don't know the status of that project, we can check. Yeah, I mean, you can do a grid plus radials, and that works really well. I mean, that's how it should work, most likely. Even Chicago is not a perfect grid. Like, I mean, there are diagonal routes, and the blue line uses one of them. One of the historic diagonal streets before they started freewaying everything. Yeah. No, the highest ridership is by far the red line. And the red line is also shorter than the blue. Battery buses, I wouldn't say kept close to the equator, because I would not call Shenzhen close to the equator. Singapore is close to the equator. Shenzhen has seasons. It's just never freezes there. But yeah, no, places like Shenzhen, Tel Aviv, Istanbul. What other places there are where like they have never committed any human rights violations, and any claim to the contrary means you should rectify yourself. Yeah, so so places like that. Do you get high energy if you? No, you get higher energy. No, you don't get higher energy density. You just don't need heating. Is Northwest Europe still too cold for battery buses? Probably. Um, like it's not going to be as bad as Moskva. Like I mean, usually the problems start below freezing, and yeah, it goes below freezing in Berlin or in London. Um, but the real problems are in places that go much below freezing, like in again Moskva, like in Russia, it's just bad. In Minneapolis, it was really bad. In Worcester, it was bad, but they kept with the experiment because only poor people ride the buses in Worcester, so who cares? If they have to walk several kilometers in a blizzard. True story. But yeah, so the higher, so it's a higher energy density. It's just that you don't have high heating needs. Air conditioning is going to be a problem, but speaking of places that have no, that certainly are not run by people who are like trying to speed run through what's it called, through democratic backsliding. I heard the other day that in Delhi the temperature goes regularly into the mid 40s in the summer. Yeah, you have to have air conditioning, and that might actually be a big battery drain. But in a place like Singapore, where you need to air condition down from 32, that's not a big deal. Like in Singapore, you need to air condition from 32 to, I mean, if you're the prime minister, 19, but 25 is fine. So you don't need to maintain that much of a temperature differential. Whereas if the temperature is negative 10, you're not going to have the bus be negative 3 inside, you're going to have the bus be 15 inside. So yeah, no, that's a lot of energy that needs to be expended. And remember, if you're burning fuel, it's easier to heat than to cool. This is why historically there was heating before there was air conditioning by several millennia. Sorry, several tens of millennia. So as I understanding, the invention of fire was like tens of thousands of years ago. In contrast, if you're not burning fuel, heating and cooling are symmetric. This is actually something that may lead to long-term changes in where people live and how people do things. But so if you're not trying to burn fuel, then if you want to have, why is this not working? Then you want to do some kind of, then you need to use electricity. Okay, it's working, I don't know why this is not working. Then you want to use electricity to produce temperature differentials, and that works symmetrically. So for example, heat pumps are symmetric. So conveniently, if your Northern European apartment is heated with a heat pump, the heat pump can symmetrically be used as air conditioning, which means that the Green Party in Germany, the party that is being yelled at for destroying German quality of life, aka large cars, for like environmentalism, is making moves that are in new buildings gonna give people air conditioning, which is kind of useful. Not for the entire year, this is Berlin, not Athena, but we're still talking, a solid month of the year where it would be nice to have air conditioning. So if you're doing electric motors on a bus, it's the same thing. Heating and cooling are symmetric, so yeah, if you're trying to cool down from 45 degrees, then lol, but most places in the world are not Delhi. Most places in the world are not Phoenix. Most places in the world are not like are not are not Puranopolis, like the Sorbonne city, no, the city that I keep seeing ads for. In Saudi Arabia, or like the actual city of Saudi Arabia, like Riyadh. So if you're like 30, 32 degrees, yeah, you need air conditioning on the bus, but that's not going to be a big deal. It's going to be like heating when the temperature outside is like 7 degrees or 10 degrees, not when it's negative 10. Uh, and yeah, so um, anyway, so with bus rail interface, going back to that, you do want, if possible, to set up things so that the buses go straight and don't have to detour, which they do in New York, they do in Chicago. That's just poor use of commuter rail for urban rail purposes. So again, we're not talking about commuter rail in the sense of doing a bunch of timed transfers in the suburbs. This is like just an urban trunk at this point. It's important. And yeah, then you have all these other trips that are piggybacking on strong radial demand, which is how subways always work. I mean, the subway is great at getting you to the Manhattan core, downtown Boston, downtown Washington DC, the loop. But because these lines pre-exist and have connections, you can also use them to go neighborhood to neighborhood. And speaking of neighborhood to neighborhood, I was asked earlier about IBX, and I don't think I ever answered. Would IBX feature some sort of bus hub transfer point? So the answer is that every stop should, if possible, have a bus connection. If it's possible based on the streets. You shouldn't detour too much. But now I'm going to use the existing Brooklyn bus network and not the redesign, which is people paid the consultancy a lot more than they would have needed to pay us for inferior product. Where's the bus? I don't want your bus redesigns, I just want the current map. Oh, you're showing me the redesign, okay. I just want to see the Brooklyn bus map, please. Brooklyn bus map, thank you. They just click on redesign or something. A map of the Brooklyn bus routes. Now, we did not think about IBX when we were doing the bus redesign. We would have to rethink, even though it is not very gritty. It's based on historic rail branches that are currently only used by freight. So the route of IBX, I'm just going to trace it here. This is the same right of way, different tracks but same right of way. So it starts here, uses the same right of way as the N. Then around here, it diverges in Utrecht. It diverges to go something like this, and you can see it a little bit as a break in the grid here. It goes through Brooklyn College. Now, because it goes through Brooklyn College, to an extent, the buses are already detouring to serve it a little bit because this is an important destination and also a subway connection. This is one of the busiest subway stations in Brooklyn. And then you can kind of see it here as a break in the grid, and then from here it goes, and again you can see the grid break up to here. Then it's the same right of way as the L, again different tracks, and then it keeps going here up to Middle Village, and beyond. What does this mean for buses? Well, yeah, the buses would need to connect to it, but it's not exactly the connection in the sense of building bus stations. Again, you should not build bus stations except maybe for intercity purposes, and even then, maybe not. Honestly, the bus stations discourse is mostly cities looking to extract rents from bus operators. So here there's already a subway hub. So buses already go there for the subway connections at Broadway Junction. So the routes from East New York go to Broadway Junction because that's already the best subway connection point. So that already comes pre-configured. Again, same with Brooklyn College. Maybe in the middle here it's not, and so maybe the crossing of Utica is not anywhere with express bus stop, so that should change. So there should be a So probably, I'm assuming that's already happening because I can't think of them being that stupid, but I'm imagining that the Utica stop would be between Utica and Kings Highway so that so there would be exits at both ends. And then, yeah, there would probably need to be another express stop here, which looks kind of ugly with how very wide the bus stop spacing on the SBS is, but that's fine. It's important to serve connecting lines, more important than keeping some kind of bus stop ideal, bus stop spacing ideal. And so, yeah, here they would add a stop, but again, it's very marginal. And I mean, or maybe Route 6, you would want to change it a little bit to service better, but I mean, Route 6 is going to end up here anyway. And more importantly, Route 6 is predominantly a circumferential, as is IBX. So circumferential routes, so things like Route 6, 35, 82, are going to become weaker. So maybe there's going to be grounds to consolidate some of them, perhaps. Already 82 and 6 are kind of doing the same thing. So I can see a world in which Route 6 maybe even stops running. Now, bear in mind, it's one of the busiest in Brooklyn. I think it's top 10 citywide. But IBX would pass so closely parallel to it that it might no longer make sense for that bus to exist. Instead, there might be 82, and then for Bay Parkway, there would be a different route that would not detour this way, but maybe a route that would, I presume there would be an IBX stop at Avenue I. So something that instead goes and then hits IBX somewhere here. That would be an option. So that is how IBX would change the bus network, but I don't think it would be really about the construction of new hubs. I guess the other thing is this route could just go direct, but I generally think that like Route 16 is just drunk and should really be two routes, one on Fort Hamilton, one on either 13th or 14th. I can see a case for both, for like keeping the one-way pair, but I mean, just one-way pairs are bad. That's a separate discussion. One of the ways one-way pairs is, one of the ways one-way pairs are bad is if they're widely separated, forces you to have bus stops at both ends when you connect. So like you see this with Church. Church doesn't have SBS, but these marked stops are unlimited routes, and because of all these one-way pairs, one-way pairs that aren't even consistent, because Nostrand on the SBS, the return is on Rogers, and on the local it's on New York. It means that each of these avenues has to have a different limited stop on Church, and this means that even the express buses on Church are slow ass. So that's a separate thing. That's mostly a bus thing. Although then when you have a cross street with a subway on the one-way pair, it also kind of sucks. Yeah, so this is how you do this on in cities that don't have a relentless grid, or in the case of Brooklyn, there is a grid, but there are several. Now, again, there has to be a subway overlay. This is where you can't just start with buses. There's a city that just started with buses called Los Angeles, and yeah, there's some subways that are just not enough. And the thing is, the bus is slower than driving. The longer it takes, the slower it is. Not just proportionally. The slowness of the bus, or rather, maybe I should not say slowness because that's weird. The trip time by bus is linear in distance, for the most part. The trip time by car is not. And the reason is that if you have such a large city basin, you will have freeways. And freeways impose their own hierarchy. In the same way that you have a hierarchy of public transit, where even purely at local level, you have the subway, maybe you have streetcars feeding the subway in Paris, for example, they have the orbital tramways. On the streetcar versus light rail topology in the United States, they would call them light rail. They practically never run in mixed traffic, but if you think of them as predominantly their own right of way or predominantly in a street median, it's a mix. T2 is own right of way, T1 and T3 are street medians. I never remember the others, but they're much weaker. The tramways that are on T1, T2, T3. But again, it's a mix. So it's kind of an intermediate level of the hierarchy, and then buses. So in the same way you have a hierarchy with cars, the hierarchy involves freeways, arterials, and local streets. Now, with cars, the way the hierarchy works is that the transition between levels of the hierarchy is much smoother. Why? If I want to travel, let's say that I want to travel to somewhere in Hamburg. How do I get there? Now I live walking distance to a train station. So in my case, I walk to Ostbahnhof. I take the S-Bahn to Hauptbahnhof. I change at Hauptbahnhof to an Intercity that gets me to Hamburg Hauptbahnhof, and then from there I take the Hamburg or S-Bahn to my hotel. Now, if I am driving to Hamburg, well, I don't own a car, but if I did, I would get in the car at the garage, which does exist in my building. Then I would drive all the way to the hotel in Hamburg. And yes, I'm eliding how I'm going to change from city streets to more arterial roads and then to the Autobahn and then in reverse within Hamburg. But there's no such thing as a transfer penalty when you're driving. You don't need to know how the transfers work. Now, it is confusing to drive in an ungridded city that you're not familiar with, but the people who make the street signs are not morons. They know that it is confusing, and as a result, they will have signs to get you to your rough destination. Now, if it's a specific hotel, historically you would pour over a map for your family trip in the car, and obviously you would make multiple mistakes in which each family member would blame the others. The two parents would blame each other, the children and the parents would blame each other. And today there are satellite, like there's GPS guidance, so you would only make one or two mistakes and then everyone would blame one another, and also mistakes in the GPS guidance, which has a tendency to not be aware of recent changes in the street network. So they at one point routed, the GPS network at one point in Nice routed my mother onto the street that had been closed into a transit mall for the tramway, which was a fun experience. She managed to get out before the tram got there, but fun times. Even that is still much less confusing than doing these multiple transfers on public transportation. So there's a hierarchy either way, but the point is that in the presence of auto infrastructure, the trip time is incredibly digressive in distance. Because yeah, you're driving a kilometer in LA, yeah, you're probably going on an arterial road, and you're dealing with arterial road traffic speed. You're going even 5 kilometers, let alone 15. Yeah, there are freeways, and yeah, it's LA. LA has bad traffic, but I mean, the freeways in rush hour traffic, are probably comparably fast to the buses without traffic. At rush hour and at rush hour alone, the trains will beat driving to downtown LA. That is important. So the trains need to exist, Again, because you need the highest level in the hierarchy. I mean, if you have a walk plus bus plus rail, or even walk plus rail system like in Berlin, yeah, then you get the same degressivity, and then the trains become competitive with freeways. They're not always going to be faster, but they don't have to always be faster. They need to be faster at rush hour, and not horrifically slower off peak, so that the rush hour commuters don't need cars for the rush hour trips, and then it's a decision whether they get cars anyway, for something that will improve their convenience. At like 10 at night, taxis will beat the metro in Paris, ask me how I know, but not by much. So if you don't need a car for other needs, you will not get a car, and you will just, maybe it's gonna be 25 versus 30 minutes for some urban trips at 10 at night. Nobody gets a car to cut their trip times at 10 at night from 30 to 25 minutes. People get a car when it's an hour and a half versus 25 minutes. People get a car when there are important trips they want to make, not just work trips, but errand trips or recreational trips that there are no trains to. People get cars when going out to eat out is 30 minutes by metro versus 25 by car. So that's how you're going to be competitive. You need that hierarchy, so you do need to build a subway. So in LA it's kind of weird because they have the grid of arterial buses. They're just really weak because they're so goddamn slow. So yeah, you can think of the subway as grid accelerators, but that's not really correct. The subway, and the planning has to go top down in the hierarchy, not bottom up. So the planning has to be subway first. Like, the subway is how people travel. Buses are how people travel in the gaps between the subway network or to the subway. Otherwise, and in LA, yeah, I mean, obviously in LA more people ride the bus than the subway because there are, how many rail lines are there in LA? Like 2 trunk lines? There's the regional connector, and it's 2 branches in each direction, and there's the red line, which is one tailed in with 2 branches, plus things that don't even enter downtown LA. Like the green line? Like, no, that's just bullshit. And so yeah, more people ride the buses than the trains in LA, but the people who ride the buses are basically all poor, and then the people who ride the trains are still, I think, poorer than average. But like, there do exist people who are not poor that ride trains in LA. There basically don't exist such people on buses in LA, and this is the failure of buses in LA. It doesn't mean that you should invest more in the buses because they're for the poor. It means that the buses are a fucking soup kitchen, and you should maybe make sure that it's not a soup kitchen but fast food. Like, people who are not poor will eat fast food. They will not eat at a soup kitchen unless they're politicians, not at all. Yeah, exactly. But I mean, I'm assuming that someone in the top 0.5% in Paris, or even top 5%, not sure about top 5%, top 1 or 2% in Paris probably do get the car for 25 versus 30 minutes, but I mean, like, even top 5 or top 10% is not always the case. And yeah, exactly. Yeah, and the thing is that it's not. Oh God, what's the problem? And then, but even like half an hour versus an hour, I don't know why this number isn't working. Oh, I see what's happening. Okay, so this is so I have internet, it's just the stream is not. Okay. And then every attempt will take longer. I don't know what's going on. Okay, I'm going to let this stew for one more thing, and then if not, I'm just going to connecting to chat. Okay, why does it say I'm online? Reconnection successful. Okay, thank you. So I am back online. Yay. Okay, so the point is that with the subway, it's not even going to be an hour versus half an hour. Often it's going to be like literally an hour versus 10 minutes. Like it's that lopsided sometimes. And um, the and so the point is that it really is a matter of having the buses work with the trains, which is kind of weird because again, LA has a bus network that is beautiful if you assume that there are 8-ish more subway lines that exist there. And I know that Toronto Art Gaming keeps asking me about LA crowning, and I did a little bit of that. Not in this computer, evidently, but I did that before I got my new computer. So that's so if those existed, I imagine that like the change, and if LA allowed more housing to be built within the city and its inner suburbs. And by inner suburbs, I don't even mean like here. I mean like technically West Hollywood is like a separate city, or Beverly Hills, or farther out, but still pretty urban, Long Beach, and Burbank, things like that. So if they did that, then yeah, obviously the ridership would increase, and that would also fill the buses, even on trips that the trains would not serve. That's how the interface works. The high ridership of trains at rush hour, where like the alternative is you get stuck in traffic and therefore you can't drive to your downtown job, and therefore employers don't locate downtown and like have to break their office into little pieces, and then productivity is lower. You let them instead have downtowns that are served by, or like secondary downtowns, where there's like big dense places that are served by trains. Yeah, that's gonna end up creating bus ridership. That's fine. Like, that's how buses and urban rail work together. That's fine. And that again, and even in the case, so in the case of a grid, like you keep the bus grid. It's just you change the intensities of surface based on what connects to the trains better. And and oh God. And yeah, so the and that's, I don't want to say that it's the same in Europe, and the reason is that in the big European cities I'm familiar with, which I mean Paris and Berlin, uh, the rail network is so dense in the city that what I'm talking about being able to use the buses to connect to the subway efficiently is very far out. Just because Paris especially is a very large rail network. It is the largest in Europe by ridership. I don't remember whether Moscow or London is number 2. Which of them is number 2 and which is number 3. But Paris has 3 billion annual riders on pre-corona numbers. I believe it fully recovered just now, or close to it. And yeah, like I think it goes Tokyo, Osaka, maybe Beijing, Shanghai, Guangzhou, Paris, and maybe even into ahead of Mumbai. Seoul ahead of Paris. I think. So, because it's such a vast network, the connection point is well into the suburbs, to the point that we're starting to talk about commuter rail. And by the way, this is somewhere where it's not exactly just a matter of, do you count it as urban rail in the core or farther? No, it actually does matter, because the Parisian network is very dense, and this means that the point where it stops being so dense that you just walk through the train is where the frequency already starts being more like 10 or 15 minutes, as opposed to 5 every 4 minutes. That's just a matter of line density. Berlin is of course much smaller, but again very strongly centered around a bunch of destinations, all of which are within the ring. There are some gaps. There are some places where buses are genuinely faster, but it's not that common. So it's mostly suburban things, or let's call them like what I showed you with Flushing in Jamaica. Now it doesn't have to be as relentless as Flushing in Jamaica, where it's just there's the Flushing collection zone and the Jamaica collection zone. Like in Berlin, if you look a little bit, I mean, yeah, these are routes that you could just connect to multiple U-Bahn stops or multiple U- and S-Bahn stops. But it's still kind of like extending the U-Bahn or the S-Bahn. Also, reminder, biggest cluster of density in this direction, Viertel does not have an U-Bahn connection due to the fact that we in the Abgeordnetenhaus have four parties that are rather incompetent at this. The four parties being CDU, SPD, the Greens, and Die Linke. And I'm not mentioning FDP because they're also incompetent, but they got shut out. They fell below threshold. And I'm not mentioning the other party in the Abgeordnetenhaus because their main shtick is not that they're trying to govern and failing at it. Their main shtick is that they are really sad that the aforementioned Austrian guy with poor taste in facial hair only got to kill 6 million. They're like intensely believe that it wasn't enough. I imagine they're also bad at it, but like it doesn't really matter what their like ideas about transport is. This is not a stream about like the logistics of the Holocaust trains. So yeah, this is again something that in very large cities with like very large rail networks, it's kind of weird in calling Berlin a very large city because it isn't, but it does have a very large, like very technically historic rail network. And when I'm saying historic, I mean U and S-Bahn. I don't mean like old tramways and shit. And that means that the buses could just connect multiple stations, things like that. So it's not quite a kind of hierarchy, but of course there's a hierarchy, but you could kind of like serve multiple nodes. And I guess that's also the case in New York and Chicago if they make their commuter trains better, because if they make the commuter trains better in New York, then you, instead of having to have a bunch of, I don't know what to call them, spider legs, tentacles, going to Flushing in a different set of tentacles to Jamaica Center, you drag a bunch of north-south routes, and then you need to probably like open new stations to hit the main arterials because the LIR was never really intended for this role. So if you build an infill station here, yeah, you run on Francis Lewis, and then you would be connecting to on a long route to both the Port Washington branch and the main line. Or in Linden, maybe I guess it would be connecting. There would be an infill here, and you would be connecting to both the Montauk line and the Atlantic branch. And then to the subway here, I guess. And and in Chicago, it's the same thing with a bunch of different commuter lines that are very closely spaced, none of which offers useful urban service in any way, shape, or form. There's branches of Metro Electric, that's the Rock Island district. They would, yeah, and you could just run north-south here, that's fine. No, not north-south, sorry, run east-west, south of the end of the red line, which I think is here. Yeah, kind of see how this is the end of the line. I guess also they co-located the bus station here. For good freeway service, as I mentioned before, and also the L connection. So yeah, this is a strong bus route, but the point is that these routes go frip rather than go this. And in the future, if they run the commuter trains better, they could just go like this and then hit, again, the like Metro Electric, and also, this could be both the express and the local and the Rock Island. And yeah, so you end up having this bus grid that kind of looks like it's not really interfacing with the trains, but it actually is interfacing with the trains, and the trains are really important because the trains are what get people to ride the bus between two largely residential, not especially high density areas of, in this case it would be the far south side of Chicago, or in New York it would be between different places in eastern Queens where car ownership is not universal but is pretty high. or the North Bronx, or places in outer Berlin or suburban Paris, where people, where because it's not the city but the suburbs, people think that Anne Hidalgo is like a conspiracist trying to like sap and impurify their precious bodily fluids, the bodily fluid in this case being diesel, and the so and with the connections between them that come from being able on the same bus to also connect to a train to city center, that's where the buses become strong. So that's how, even if you don't, even if you're not having these specific detours the way that Chicago currently has, or if you don't have something that looks very like, if you don't have a network that looks very dendritic and very explicitly hierarchical, you still have that hierarchy, and so that's how they work. Do I think I will live to see 10 million Berliners? No. Germany is not a fast-growing country. There's a vague pro-immigration consensus here, but it's pro-immigration in the sense of like letting people in at like distinctly sub-Canadian or sub-Australian rates, and the birth rates here are garbage, and the immigrants are not all going to move to Berlin, or even, I mean, maybe disproportionately to Berlin versus rural Saxony, but not disproportionately to Berlin versus München or Frankfurt. So we're still talking, so 10 million Berliners, even if you count all of Brandenburg, that's, 110, 120 million Germans probably is what needs to happen for that. No, with Brandenburg, we're already talking about like East German, like proper East German declining areas. So talking 130 million people in Germany, and I kind of don't see that. Again, Germany is not that aggressively pro-immigration. By the way, are there other questions? Is where we're wrapping up. And I'm sorry that the stream kind of. I'm seeing most people are back, so we have 10 now. What's the lab? It looks like a 25 second lag, 27 second. Gonna give it one last go for questions. Oh, how good are German cities' bus model splits? I have no idea. So the problem with this is that model splits are reported for all trips and not work trips, and this means that if you're trip chaining, you count as multiple trips, so it's not the best to figure this out. Second thing, now I could look at ridership by mode, but that I'm pretty sure would be unlinked. And so I would not be able to tell one bus trip from multiple bus trips, let alone, and there's no way I would be able to tell a pure bus trip from a bus U-Bahn or bus S-Bahn trip. So the answer is I don't know. And because I don't have, and because the other thing is, like, I can, for cities with a dominant mode, thanks for watching Process Line. For cities with a dominant mode, like the subway in New York or combo metro and Transilien, I can kind of look at rail ridership and not have too much double counting, and Tokyo is the big exception, where the rail ridership per capita will give you wrong numbers. If you're thinking about model splits, and vice versa, like Tokyo is, I think, 400 rail trips per capita per year. The model split's probably about 50-ish% maybe. For work trips, and in Paris it's like 40 something, and you're getting, and because there's less double counting from like fewer different operators, you're getting maybe 240 per capita per year. In Berlin is I think 200, and the model split is 33%. But the rail trips in Berlin include the straight cars, and I'm guessing there's more U-Bahn to S-Bahn transfer than Metro to RER in Paris. And so, yeah, so I can adjust this for rail with like some sanity checks, but I have no way of adjusting the same from buses. Like I don't have a good, because like if it's a pure bus system, like pure bus cities have such bad public transit that you can't. I mean, what am I gonna do? Like try to figure out like the relationship between bus ridership and model split by like extrapolating from like American Sun Belt cities. Like it's 0 divided by 0. You can create. I mean, there are global standards, but they kind of suck. About remember there are two standards for model splits, which are all trips and work trips. The world within which I have this data is actually split pretty evenly on that. I guess more work trips than all trips because Japan, the US, Korea, France, but I mean Germany, Nordic countries, and Italy, and I think so Spain are pretty hefty, especially if you ride a ship rate. So they're going to be obviously not going to be overrated relative to Japan, but the US is going to be severely underrated. They gotta know whenever in developing countries, like in developing countries, when I'm seeing reports about like essentially analysis for like whether they need a mentor, and the answer is pretty much always yes, please, and then they don't have any way of domestically financing it, or they do but they don't want to raise taxes for it, so they try to sell themselves to the ADB or to China or whatever, and then things suck. But they do mention model splits, but they're inconsistent in whether the model splits are all trips or work trips. They're also inconsistent. They also sometimes give you crosstabs, like by different income levels, and sometimes also will do things like point out the much lower incomes of bus riders in Bangkok compared with drivers. And my recollection is that the like 6% of people in Bangkok who commute by MRT actually have pretty average incomes, like same as drivers, whereas and then the bus riders are significantly poorer. Do I think China does well on model splits? The big cities do. I just don't have penetration for how it looks beyond, Beijing, Shanghai, Guangzhou, Shenzhen. My understanding is that the smaller Chinese cities, like the ones with like 2 or 3, 4 million people, are by the standards of European cities of the same size garbage. But I mean, it's not like Busan is much of a transit city, or Kaohsiung is not much of a transit city. Niigata, I don't think is much of a transit city. Maybe I think Hohhot is actually worse than like the let's say Busan, Niigata, Sapporo, but so a lot of it is like relative to city sizes, and the answer is I don't know. I don't know to what extent it's an East Asian pattern versus something that's not East Asian, maybe Soviet. My understanding is that you have these Soviet cities with like 1 million people and 1 metro line and like 3 riders, and the ridership in it's like how the Baltic states have rather no I know the Sapporo is pretty decent, but I mean, yeah, you need to include that when you're talking. I mean, we're not excluding Sapporo when we're talking about medium-sized East Asian cities. It's stupid. It's like saying, oh, let's look at European medium-sized cities, but exclude Praga, Budapest, Stockholm, and only talk about Copenhagen and Amsterdam, where there's much public transit ridership because bikes or something. Or Brussels, where cars. Or Birmingham, where provincial England. Yeah, so I can't tell you whether China does well. I don't have enough information, and the information I do have is in cities that are so vast that, yeah, of course they have buses in Shanghai, but like Shanghai is big enough and builds aggressively enough that like certainly in the city core I'm sure there are buses. I don't think they need to exist. So yeah. Are there other questions? Sure, no problem. Um, yeah, what's the lag there? The lag is the quality of the. Okay, 24 minutes. I can. It's a blur, but I can see the change in the. Yeah, so thank you all for watching. And I will see you once again in the next one, either 4 days or a week. Thank you, and ciao ciao.